Hello everyone, welcome back. In previous lecture, in the chapter drilling machine, I explained about the various drilling machines, and in today's lecture we will see about the job fixing clamps. So let us start. Before that, let us recall what we taught in the earlier lectures. So, in earlier lecture about the introduction and the classification specification, various types then of the drilling machines. These are the various types I explained earlier. Then the various drilling operations, which were the reaming operation, boring operation, which was the what was boring? The enlarging existing hole, while was the reaming was for the finishing purpose. Then the counter boring, that is used for the flat faced enlarged hole for fixing a bolt or nut. Then the counter sinking, that is for the conical shape. If you want to fix a screw, then we can use the counter sinking tool. Then the spot facing, that is for the flattening the face for perfect fitting of the nut or the head of the screw. Then tapping operation, that is for producing internal threads. The tap type of tool is used. After that, there was the trepanning, that was for producing a hole using a hollow cutting tool for producing large size of hole or grooves around it. And then the deep hole drilling, in which the rotating tool or rotating workpiece or the counter rotating tool and workpiece can be used. Now we will see about the various work holding device. The type of work holding device used on drilling machines depend upon the shape and the size of workpiece, required accuracy, and the rate of production. So what are the requirement over here basically for using the different types of work holding? First thing is depending upon the shape and size of the workpiece. What is the shape and size of the workpiece? Second most important thing is the required accuracy, and third most important thing is the rate of production. If the work holding device is very much complicated, then it will be consuming more time to fix the workpiece. So these 3 points needs to be kept in mind while selecting the work holding devices. First thing is the shape and size of the workpiece, second accuracy, and third one is the rate of production. So depending on that, the various types of work holding devices are available in the market. We will see one by one. First one is the machine wise. Here the what is the use of machine wise? Machine wise you have seen in the uh, machine shops the normal types of wise that are used for holding down the workpiece. This is the simplest type of my work holding device. It is generally used for the holding the round workpiece or the square workpiece or the odd shaped rectangular type of workpiece, and clamp wise to table for stability. It is clamped to table for stability. Another type is the V block. V block are made of cast iron. Here the V-shaped block is used for holding the cylindrical or round shaped workpiece, used in pair to support the round workpiece. They are used in the pair to support this workpiece. Not a single but double are used, and four faces of the V block are in V shape, or here is the rectangular shape is there for clamping over here. Okay, so these are the various two types. First one is the machine wise, second one is the V block, another is the step block. The step block are here, you can see the step by step blocks are used, and there is one stepping clamp is there used to provide support for the outer edge of the strap clamp. Suppose this is the one workpiece and we want to support or fix over here, so we can use this step block to support or the this portion of the nut and perfectly fix the work over here. And angle plates, L-shaped angle plates of the cast iron or hardened steel machined to accurate 90-degree may be bolted or clamped to table. Suppose the horizontal table is there and we want to drill a horizontal hole at here in the 90-degree. So the clamp angle plates will be very much useful for this purpose. The angle plate, this portion is suppose mounted to the work table, and over here suppose the workpiece is mounted. So we can drill a horizontal or vertical or type of hole as well using the angle plate. Then there is the jigs. You have heard about the jigs. Jigs are used for both guiding the tool as well as for holding the workpiece. Jigs are and the fixture is only for clamping or a workpiece. They do not guide the tool. Now the jig is used in production for drilling hole in large number of identical parts. In large number of identical parts, it is used for drilling and eliminate need for laying out a whole location. Eliminates the need for laying out a whole location. Here the drill bush work and locating pins are used. Then clamps or straps are used to fasten the work to table or angle plate for drilling, usually supported at the end by step block and bolted to table by T-bolt that is fit into table T slot. These are also clamps or straps that are used to fasten the work to the table or angle plate for drilling, for to the angle plate or directly to the table, and usually supported at the end by step block or and bolted to table by T-bolt. First fits into the table T slot. Okay, so this is about the this six uh, types of the devices. First one is the work holding device is a machine wise V block, step blocks, angle plates, jigs, and clamps or straps. Next, we will see is the various tool holding devices. Now, after work holding devices, there are various numerous number of the tool holding devices. One is first one is here is the drill chucks. Similarly to the chuck used in lathe machine, here the drill chuck are used. They are most commonly used for work holding straight shank cutting tool. The shank of the cutting tool is straight, and the most contain three jaw which move simultaneously when the outer sleeve turns. When we turn this outer sleeve, this three jaw will slide into this. So this is the similar to the most likely similar to the chuck used in the lathe, but the difference is it is of a small size, and this rotating sleeve is used to slide this three jaw, and the uh, cutting tool end portion is of flat shape. Hold the straight shank of cutting tool securely. The two common type of are the first one is the keyed and second one is the keyless. You have seen this keyed type of drill chuck. It is the three jaw movable simultaneously. Here there will be the three jaw one, two, three over here. And when the outer sleeve is turned, the tightening with the key is used to tighten it. The different size of key for different size chucks are available. And the keyless, the chuck loosen or tighten by the hand without key. Here no key will be used and it is tightened or loosened with the help of hand. and holds smaller drills accurately. It is used for holding the smaller drills very accurately. Then there is the drill sleeves and sockets. Drill sleeves used to adapt drill shank of machine spindle if the taper of the tool is smaller than taper in spindle. So drill sleeves, when the taper is small, it is used to adapt it, and the drill socket are used when the hole in the spindle of the drill press too small for taper shank of drill. So using usually used for extension socket. For extending it, it is used. Drill sockets are used when the drill tool cannot be directly mounted in the spindle. Okay, so we can use these drill sleeves. Then there is, after drill sleeves and sockets, there is the drill drift used to remove the tapered shank drill. First, we have fixed the tool. Now we want to remove, so we can use this type of drill drift, which is here in this hole. You can see when we fix the tool here, the drill tap is inserted, and we will drill drift is inserted, and we can remove the tool from it. So used to remove the taper shank drills or accessories from the drill press spindle. Always place around edges of up to up, so this edge will bear against the round slot in spindle. Using the hammer or the tap drill drift loosen and tapered drill shank. Use the board or piece of the pressed wooden or protect table or vice. Next is the alignment test in the drilling machine. Now, all the machine tools used for producing need to be tested at the time for first installation, and the periodic during used to ensure that they have the capability to produce the accuracy and finish expected from them, continues to have such capability even after the use. So geometrical characteristics and various movement are tested the same way for as lathe alignment. Here the first we will measure the perpendicularity of the drill head guide with a table. That the table and the drill head is perpendicular to each other or not. In the This test is carried out with the help of block of the square or the frame level in the two planes. First one is in a vertical plane passing through the axis of both spindle and column, and plane at right angle to the above plane, at a right angle and at the vertical level. There are the two block square or the frame level are used to carry out this test. Block square or the frame level for uh, level with graduation from 0.03 mm to 0.05 mm per meter is placed on the guide column, and table and lever reading are noted, and the permissible error is also noted, and it is having the incline at upper end towards the front, which is 0.2025 per 1000 mm with the column, and for B it is up to 0.15 mm per 1000 mm for the vertical one. So in this way we will check the perpendicularity of the drill head guide with the table. Then there is the true running of the spindle taper. This test is carried out with the taper test mandrel attached to the tapered board spindle. Here the dial indicator is kept on the table and the plunger is touched to the mandrel. The rotating spindle slowly notes the dial reading and permissible error up to 0.03 mm per 100 mm is acceptable. So for this we will use the true running of the spindle taper. Then the parallelism of the spindle axis. The same way we will also check the parallelism using this test mandrel, and for this also the same will be used checked for the both the axes A and B. Reading will be taken for checking the parallelism of the spindle axis with the vertical movement. Keeping the plunger in touch with the mandrel, the spindle is moved up and down with the slowly vertical feed motion. Then, after the parallelism, the last one over here, the parallelism after is the squareness of the spindle axis with the table. Now, the spindle axis is square or not with the table is that is also checked. In this, the dial is set as shown in figure, and the table is kept in the middle over here of its travel, and the plunger of dial is kept at a position P, and straight edges P and Q on the table, taking the reading for the position P, then rotated the spindle through 180 degree. So the dial is now at the position Q and again taken the reading. The difference between these two readings is the error in the squareness of the spindle axis. For the table, shift the straight edge from R to S. Again, for taking the reading, and the permissible error is 0.08 mm per 300 mm for position P to Q, and 0.05 mm per 300 mm for R to S. So this is the end of this chapter, and you can use this reference book to study further. And thank you very much for listening me carefully. Have a nice day.